Okay, so last time we just stop here. We just stop here. So let me just quickly just give you a review about Riemann sum. The Riemann sum basically is just like this one. If you want to understand its sum, Riemann sum, the way we just do for that is, if you are giving y is equal to f of s, so we will assume the function is integrable. Later on, I will show you what is the integrable. Okay, so if the interval we focus on is from a to b, so we will try to pick up some point between a and b, like s1, s2, t, sn minus 1. So including two endpoints, totally we have n plus 1 in subinterval. So that means n plus 1 points, so that we can have n subintervals. So let me emphasize it again, that actually in the beginning, when you just pick this point, it could be very random. So that means the length for each subinterval could be different. Okay, so this x plus 1 point can form a partition for a and b. So there are infinite number of possibility to have this partition. So when you just pick up s1 to s minus 1, then you just pick one of the possibilities. Okay, so for each subinterval, we can just define it like s0 to s1, s1 to s2, blah blah blah. So for each subinterval, we have its length. We denote it as delta Sn or delta Sk. So based on this idea, you can see delta Sk just like the width for the rectangle. But how can we just get the height? The height will be, okay, because right now you have n subinterval, right? So you can randomly pick Ck as is like as for the Sk minus 1 to Sk's sample point, then we just use this sample point to get its height, so that we can have f of Ck minus 1, something like that. Then use the height for the rectangle, so finally you can see f of Ck times delta Sk will be the area of the rectangle. Then we just sum them together. So we will say this is the Riemann sum for this partition. And especially we will define a very special term that is the norm for P of P. So the largest one of the all subintervals width, then we will define is a norm. So last time we already practiced how can we just get the norm. For example, if we pick 1, 2, 3, 4, totally 6 points, then we can have 5 subinterval, and the largest one would be 0.5. So we will say norm P should be 0.5 in this case. Okay, so norm of P just used to define the largest subinterval, its length. Okay, so then today we will continue to introduce what is the definite integral. So what is the definite integral? So compared to definite, we already learned indefinite. Remember, it should be in section in sections 8 of chapter 4, indefinite integral. We learned that in section, as I remember, section 8, right? 8 or 7. Or 7, sorry. We learned this. Right now, we just try to learn what is the definite integral. Okay, so the definition here is, so what is definite integral? The definite integral just defined as a limit of Riemann sum. Riemann sum. So just right before this section, we just already learned what is the Riemann sum, right? And then we try to get its limit, then it will be the definite integral. So let f of s be a function defined on AV. So remember, I give you f, but also give you a b interval. But when you just try to get the indefinite integral, you don't need to have a b interval. But for the definite integral, not just we need to have y is equal to f of s here, but also the interval with focus. And we say I is the definite integral of f of s then over AB. That it is quite similar to epsilon and delta. So if given any number epsilon, we always can find a delta such that for any partition P, we just have the partition as S0, S1, S2, blah blah blah, Sn-1 to Sn, and two ends A and B here, right? So in total, we have n plus 1 points for n subintervals for this partition. So when I give you epsilon, you always can give me a delta such that for the partition with non p less than delta. Okay, so that means the maximal length of the subintervals will be less than delta. Okay, then and any choice, remember any choice of ck in sk minus 1 to sk, we always can have sigma k is from 1 to n f of ck f of ck times delta sk minus I will be less than epsilon. Then we will say that I is integral, the definite integral from a to b, f of s is the integrand. Then ds means we just integrate f of s with respect to x and x range from a to b. So you can see this quite similar to the precise definition from which I learn limits, right? So you can see this is a partition, but I use delta to constraint. So that means if you give me any epsilon, no matter how small it is, I always can find a delta. Then the delta, even though maybe we can have an intuitive idea about epsilon delta, right? Epsilon delta means when we just learn the concept of epsilon delta for the limits, then we remember this is for confined x. If s is approaching x0, then f of s will approaching L. So no matter epsilon is maybe relatively large, but maybe it's very small. But if epsilon is small, we can expect delta should be very small. So no matter how small it is, we always can find a very small delta to be a corresponding length to confine the partition. Then this is the Riemann sum, right? This is the Riemann sum. So the Riemann sum, the value of the Riemann sum will be very close to the I. No matter I give you different epsilon, you always can respond to me a delta. And then these two numbers will be very, very close. Then we will say the definite integral from A to B f of s is equal to I。这边呢，大家如果从这边我们就没有像极限的时候啊讲的那么给大家去特别拿个例子来练习。不过我觉得大家慢慢应该可以隐约感觉出这个epsilon delta的概念了，对不对？当初在这个极限的时候，我们是epsilon delta是说，不管你给我多大的epsilon，我永远可以找出一个 delta。那时候是在控制什么？控制 S 的范畴，我一定可以找到在 S 减 S0的范围小于这个 delta 情况之下呢，我的函数值它位置也在这里，跟我的极限值呢会非常的接近。记不记得那时候有跟大家举一个例子，不管多小的epsilon，我永远可以找到一个足够小的 delta， 让你落在那个区间里面的点都会落到它这个框框里面去。所以这边也有点这个概念哦。那不同的地方是什么？这个 delta 是用来控制你的 norm。那刚刚有定义过 norm 是什么？ norm 是 subinterval 里面宽度最大的那一个。那这个代表是什么意思？你给我不同的epsilon，我永远可以找到一个 delta。所以这个即便很小很小，我永远还是可以找到一个很小的 delta 去 confine 你的 partition。哦，那注意看哦，这 n 减1也是不固定的哦，它不是说我固定要切100个，我可以切10000个，只要我的 partition 呢满足你找到这个 delta 呢，我最大的 partition 呢，最大的那 subinterval 不会超过你这个 delta。如果这件事情发生存在的话呢，我在这种 partition 情况之下呢，你算出的 Riemann sum 呢，跟你的 I 值也会越来越接近的话，那我们就说它的definite interval 就定积分中文叫定积分就等于这个 I。所以大家可以去想象这里面的它的非常的要求，它的要求的这个情况呢，事实上有2个部分第一个是你的 partition， 对不对？你的 partition 呢，这写 n 减1，这个 n 没有固定的，但是你这 partition 要满足什么？我任意找到这个 delta， 这个 delta 让它的最大的那一块不会超过这个 delta， 这是第一个。第二个件事情是什么？你还要符合什么？你这样自己如果切出子区间出来之后，每一个子区间你要任意取 ck 哦，也就是说 sk 到 sk 减1到 sk 之间，事实上它点有无数多个点，我随便挑一个 ck 我都要让它带进来所得跟这个长度宽度乘起来的黎曼河要跟这个 I 呢很接近小于epsilon的概念是这样的。如果我永远可以有这样的关系呢，那这个就是我的定积分。 哦，这是一个比较抽象的定义了哈，让大家稍微了解一下，也就是任意的 partition 哦，注意看两个重点哈，这是任意的 partition 哦，是蓝色，大家看得到吗？哦，蓝色看不太到，任意的 partition， 还要任意的挑点，哦，这是一个非常难达到的一个工程哦。但是它如果你可以达到这样子，哎，那我就说你的定积分存在哦。Okay, so then I will give you an example that if I ask you to calculate integral from 0 to b s dx and try to find the area A under y is equal to x over 0 to b. Okay, so let's just go for this part first. So if you want to calculate this, that means you need to follow this one, right? You need to follow the Riemann sum. So of course, at this moment, we just assume we don't know how to solve the integration very efficiently. That means we will not use any formula. Here, we just follow the very original definition for the definite integral. OK， 这边呢，大家看到这个积分，我们快讲一下概念是，算这个积分呢，或许后面我们学到很快的，透过那个微积分基本定理可以算得很快，可是这里要假装自己没有学过。OK， 我们不知道可以用反导函数来算这个积分，我们要先 follow 我们所学到的这个所谓的黎曼河来算这个哦。OK， so that means we are focusing on here is your FOS, right? So that means your function just focus on y is equal to x. This is the integrand we focus on, right? Then the interval we focus is from 0 to b. So that means here is 0, then we focus on the endpoint. The second endpoint is b here. So following the Riemann sum, the definition of Riemann sum to get the definite integral, we need to have some partition between 0 to b. So we just take delta sk is equal to b minus 0 divided by n. B minus 0 means the total length for this whole interval. But divided by n means we plan to divide the interval into n pieces with equal width. So that means this is b over n, then this is 2b over n, blah, 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 here to some point, sk minus 1 to sk. Then finally, this is the k, this is also b 1 over n, this is 1 over n, this is 1 over n, then here is 1 over n. Okay, so this is n k. This is the first piece. This is the nth piece. Okay, this is nth piece. So we just follow this to divide the interval from 0 to b. So the partition is equal to 0 b over n to b over n dot here k minus 1 n b, then kbn dot here n over n over nb. So that means this is b, this is 0, right? Okay, so then in addition to the partition, we need to choose ck to be the right endpoint so we just assume ck is the right endpoint. So that means if we just focus on this partition, we just pick ck as this one. So this is the f of ck for this subregion. Okay, so of course you can pick any point between s k minus 1 to s k, but in this case we just pick the right end point as its sample point. Okay, so based on this partition and based on the rule how we pick the ck, then we can get the Riemann sum as sigma k is from 1 to n f of ck times delta sk. So it will equal to sigma k is from 1 to n. Then because f of ck, we always pick the right endpoint. So that right endpoint is kb over n, right? Because you can see for this subinterval, this subinterval, then we just pick the right endpoint as its ck. So that we will pick f of ck, that means through ck is equal to kb divided over n, so that we can have kb over n, because this is an identical function, right? So if you use ck as an input for this function, you always get ck back. So right now we just use kb over n as an input. So of course the return value will be still kb over n, then times what's the length? For each subinterval, the length is always 1 over n, right? Because we just equally divide the interval from 0 to b, right? So based on this, we can get sigma k is from 1 to n kb oh no, sorry, for each subinterval should be sorry, the total length should be b, right? Total length is b, so for we just divide it by n, the length should be b over n. So this is b over n. So that will become this one. So that means k is from 1 to n squared kb squared. So we can continue to get because based on this expression, we can know this part is constant, right? Sigma k is from 1 to n, k times b squared over n squared. This part could be the constant, so we can then move it out. Then only sigma k is from 1 to n k left, so that we can have b squared over n squared times n plus 1 divided by 2. Okay, so then we can have b squared divided by 2, then 1 plus 1 over n. Because this is n squared plus n, right? This is n squared plus n. So divided by n squared, we can get 1 plus 1 over n. So as norm p is approaching 0, so that means n is approaching positive infinity, then we can get the final result will be b squared over 2, right? Because this term will vanish. So finally, we just have b squared over 2 here. Okay, so that you can see the integral from 0 to b, by following y is equal to x, the result is b squared over 2. And at the same time, if you just try to use the formula for the area, you can see here is b, right? So if you follow this one, it will be, this is a triangle, right? Here is b, right triangle, here is a b. So actually, the answer will be b times b over 2. So actually, same as this one, right? So you can compute the integral, and you can also find, by using the traditional way to get the area, you can still get b squared over 2. Actually, they are the same, right? They are the same. 好，很快跟大家说一下，这个题目是一个要我们算它的定积分，一个要我们算用传统方法去算它的面积啊。那等等我们也会讲，如果这函数是正的话呢，在这个 AB 区间它是正的话呢，事实上正的面积跟你的积分的值啊会是一模一样的。但是如果这函数乘以到负的，那就不会一定就不会一样了哈。好，那这节题目的意思是要让你看到，就是说，如果我尝试去做一个函数正的函数的积分的话，其实它跟它的面积是会等同的。好，这是第一个重点要讲的。好，第二个，这个要你去算这个定积分，从这个定积分的式子，你要去理解出它的被积分式子是 f(x)， 你的区间是0到 b。那做法是怎样？根据黎曼河告诉我们什么？你随意的去切割它，随意的去取这个点来取得它的高，把它加总起来，不管怎么加呢，它最后的值啊，会跟你的定积分的值会接近的。所以既然是一个随意切，对不对？随意切里面的一种切法是什么？我在0到 b 之间呢，做等分割的切法，大家同意吧？对不对？随意切，我可以忽大忽小的切啊。一开始教大家在黎曼河的时候是忽大忽小的乱切。那在乱切的过程当中呢，每一个子区间呢，我是乱取点。那这些随意取点、随意切割、随意取点，最后的加总的黎曼河都会趋近于 i 了，因为大家到最后都会趋近于 i。那既然要趋近于 i， 其中有一个可以计算的是什么？我就把它等分割。特别等分割里面呢，这刚好是个递增函数呢， 我就随意取点呢，我就可以取右边的这个点。大家可以回去可以想一想，回去可以重新推导这件事情。如果我随意取点取它左边点呢，到最后其实也会一样的，因为它是一个可积分的、可以算积分的一个式子，所以不管你现在是暂时取右边或暂时取左边，甚至暂时取中间，你算出来的总额在 n 趋近无穷大，也就是 p 弄趋近零的时候呢，你到最后都趋近这个值。哦，这也还可以直观的去想，就是说我这边的取这么多，对不对？但是我我去到弄 p 趋近零，代表什么？我最大的最长的那个区间呢，必须趋近零，就是萎缩到变成一个点的一个面积，对不对？所以如果是这样想法的话，不管你先取左边、取右边、取这边的点，到最后它到最后都会收到这样一个点，所以每一个点都是它自己的高。这样你要懂我意思吗？好，所以到最后它其实都趋近这个。好，所以这个题目给我们两层意义哈。第一个就是从面积的角度来看积分，从面积的角度来看积分。另外一层意义是什么？如果我今天要任意取点、任意切割的时候呢，我可以找一个 doable 的，找一个可以算的来算，因为到最后大家都会万流同宗了哈。到最后呢，你不管怎么切，不管怎么取点，最后它就会趋近同一个 i， 因为它是一个可积分的，可以算它出它积分值的哈。Okay, so this is the basic idea about the Riemann sum and the integral especially for definite integral. So if I continue to ask you, how about integral from a to b x dx? Actually, the answer is quite simple. It should be b squared over 2 minus a squared over 2. Because it's quite easy, right? For example, this is y is equal to x, and here is a, and here is b, right? So for you can just use this integral, subtract this one, right? So here you can see it will be integral 0 to a s dx, right? For the green part, it will be 0 to b s dx. So of course, if you want to get this one, if you want to focus on this one, you can just use this to do. And later on, we will show, actually, you can just even use the antiderivative to get this one. But later on, I will prove this part. Okay, so this is the extension for this example. Then we just continue to focus on the integration. That there is a theorem that what is the integrability of continuous function. So you can see this is integrability. So compared to differential, we have a differentiability, right? Differential, we can differentials come from differentiation, and differentiability, that means if we can just differentiate the function. For integration, of course, we have integrability, but it's a little bit different from that one. If a function f of x is continuous on AB, or f of s has at most finitely many jump discontinuity there, then the definite integral a to b f of s dx exists, and we will say f of s is integrable over ab. So let me just describe the idea to you again, that if the f of s is continuous, no doubt is integrable. 如果它连续，一定可以积分。Okay? The second case is if f of s at most finitely many Jenq discontinuities. So that means if the function is not continuous, just like, for example, here is still A, here is still B, but here to here, maybe like this one, then jump to another point, like this one, then here, like this one. So it is quite obvious that if y is equal to f of s, if its curve is just like this one, you can see it's not continuous. Like if this is C, this is D, we can notice that at C or D, the function is not continuous. So that means we have two discontinuity in this case. So even though for this case, actually is still integrable, even though it's not a continuous function, not like for function. Did you remember for function, if we want to discuss its differentiability, it should be continuous. Did you remember? We just learn limit, then continuous, then differentiable, right? Differentiable is the strongest one, right? If the function is differentiable, that means it is continuous, right? But continuous, if the function is continuous, doesn't mean the function is differentiable, right? But here, even though the function is not continuous, if the Jenq discontinuities are not so many, not infinite number, then we will say it's still integrable. Okay, so this is for this part. So then I will show you an example that a non-integrable function on 0, 1. So we just define f of s is equal to if x is rational, then we define the function value is 1. But if f of s is irrational, then the function value is then 0. So this function is not integrable. This function is not integrable because this function has infinitely many Jenq discontinuity. But we cannot say that we cannot just say that. We need to prove why it's not integrable. So let me just show you how to do that. So let's just prove it. If f of, we assume f is integrable. We assume it's integrable, but later on, I will show you there exists some conflict. Then our assumption is wrong. So at this moment, we just assume f is integrable. Okay, so we can pick a partition P of 0 to 1 interval, right? And we choose CK on subinterval SK minus 1 to SK, right? Just like I say, we always can divide it into many subintervals. We can divide it into subintervals, then randomly pick CK, right? If it's integrable, no matter you pick, no matter you divide the interval, you always can converge to the same number I. So at this moment, we assume it's integrable. So we can randomly pick a partition, we can randomly pick CK for each interval, then its Riemann sum should be sigma k is from 1 to f of ck times delta sk. So that means if this is 0 to 1, so we can randomly divide it. For example, this is sk minus 1 to sk, right? And then blah, blah, blah. We have so many pieces, right? So this is the delta sk, right? Then we can randomly pick ck. Maybe ck is here, this is ck. So we just try to get its Riemann sum. So for each f of ck times delta k, then we just make a summation for all subintervals, then we can get its Riemann sum. Okay, so in this case, if all ck's are rational, so its Riemann sum will be sigma k is from 1 to n. Then when you get f of ck, since it's rational, right? So its return value always 1, right? Always 1. Always 1 times delta sk. So the result will be sigma delta sk. So finally, the result will be 1. Why is 1? Because you can see the total length is 1, right? I just divide it into several subpieces. So each subpieces will contribute delta sk, delta sk, delta sk1, delta sk, delta s1, delta s2, delta s3, then delta sk. So after I sum them together, this will be the total length, right? But if all ck's are irrational, so its Riemann sum will become sigma k is from 1 to n. Then because irrational, so it should be return 0, right? Times delta sk. So finally the result will be 0. So there is conflict, right? If it's integrable, no matter the partition I pick, no matter ck I pick for each subinterval, finally the Riemann sum will converge to the same value. However, you can see if I just assume, I just pick all ck which are rational, then the Riemann sum will be 1, right? But if I just pick all pk which are irrational, then its Riemann sum will be 0. 1 is different from 0. So there is a conflict. So it should be not integral. Okay, so this is a very typical example that so as I told you that if the discontinuity, we just have infinite many jump discontinuities, we still can make the function integrable. However, if your discontinuity, as for your discontinuity, you have infinitely many, then actually it will be a non-integrable function. 好，这两页呢要一起来看一下啊，就是说，今天呢，如果我们今天在谈这个可积分的时候呢，事实上呢，我们在意的是这个函数有没有无限多个断点。如果它只有限个，哪怕它是100万个，只要有限个，它都是可以积分的。好，比方说这个例子，对不对？这里有2个断点形成3个小段落，没关系，它其实还是可以积分的。但是反过来说，如果你的断点是无穷多个，像这个，我们都知道0到1之间，假如有个函数被定义成有理数，它就是1；无理数，它就是0。其实这是一个不连续的函数，甚至是一个有无穷多个断点的不连续函数。那我们就证明它也是不可积分的。那我们证明方式怎么样？我们就一样用矛盾证法，我们证明说它呢是可积分的。那根据黎曼河的定义，根据黎曼河来做可积分的定义是说，不论你怎么取这个 partition， 也不论如何，你在这 partition 之下的每一个子区间，你取的哪一个代表点当做你未来算这高度的点，你加总出来的黎曼河啊，如果是可积分的话呢，他们应该都要收敛到同一个 i 值，然后在这个假定情况之下，你既然说它可积分呢，那你就经得起我任意的挑这个点了，对不对？所以一种取法是，我在 ck 里面的每一个子节点里面的子区间的挑点上面呢，我全部都故意挑是有理数。那根据这个定义的话，如果是有理数呢，算出来每一个子区间的高度值应该都是1咯。那1乘以 delta sk。delta sk 是它的子区间的宽度，所以把整个子区间宽度全部加总起来，那就只能1了。反过来，如果每个故意这个刻意去挑无理数，因为每个子区间里面，每一个小子区间里面呢，它又继续拥有无穷多个有理数的无理数的点，所以我又刻意去挑无理数的点，就造成它函数值算回来应该都是0。那既然都是0呢，乘以每个段落呢，它最后的加总出来是0。那你会发现，这是它的一个黎曼河，这也是它的一个黎曼河。可是，当你的 ck 的挑法不一样的时候，你竟然会形成不一样的黎曼河，那就矛盾了。矛盾代表什么？你当初的假设根本是有问题。这样了解我意思吗？这个逻辑的推论是这个顺序哈。Okay, so before we take a break, I just show you some theorem for the some formula for the integration. So this is about if f of s, g of s are integrable on AB. So the first one is if integral from A to B f of s ds will be negative if you just change it from B to A. Remember, you will have a negative sign here. So the order is from A to B, then you change the order to B to A, then you need to add an extra minus sign here. The second one, if A to A, the answer will be 0. Because A is a single point times the height, then the result is 0. The third one, integral AB k times f of s dx, it will be, you can just simply move k out of the integral. The first one, integral AB f of x plus minus g of x ds, it will be integral AB f of x ds plus or minus integral AB f of g of x dx. So remember, not included multiplication and division, not included. Only addition and subtraction can work, but for the multiplication and division, actually they are not included for this formula. And for these two parts, we will find some extra section to solve. Okay. Then the fifth one is integral from A to B f of s dx plus integral from B to C. Then the answer will be integral A to C f of s ds. Actually, you know, we just use this formula to prove, to get a very good journal paper. We just regard the streaming, you know, streaming service. We just regard f of s as the packet function for some streaming service. Then when we just divide it into two parts, and then it will become, actually, if the breakpoint is the same one, actually they can link together. So we just use this one to have my first journal paper in this university. 我甚至用了这个公式啊，就用来做那串流服务的证明啊，哈，也就这么简单哦，就这么简单的一个公式而已。哎，我们也拿到一个期刊的文章哈，发表在Computer Network 哦，所以我觉得微积分里面有很多宝藏，然后大家去细心的去发现很多公式，甚至就是一个不错的论文。不过你要把它联想得到了哈，这是比较大的问题。哦 OK， so the sixth one is if f of s a maximum value, we call it max f, and a minimum value, we call it MIF over AB. Then we can get MIF f times b minus a should be less than or equal to integral a to b f of s ds, then less than or equal to max f times b minus a. So it's also very intuitive, right? So if this is a function from a to b, right? So this is the max. Then this is the min. So your integral is in between, right? So of course, the integral here should be larger than this area, right? And less than this area, right? Because your curve just sit in between, right? So I believe this formula is also very intuitive. Then the second one, the next one is domination. They say if f of s is always larger or less than g of s on AB, so we can have integral AB f of s ds larger than integral AB g of s ds. It's also very intuitive, right? Because the function value on AB, f of s is always larger than g of s. So when you just integrate them together from A to B, of course, the value of the integral must be larger than the one for the integral from AB g of s, right? So especially if f of s is positive, so we can conclude the integration is also positive, right? Why? You can just regard g of s is 0, and you can follow this idea, then you can prove if function is positive, when you just integrate a to b, it is still positive. Okay, so before we take a break, then I give you some simple example, because I believe these examples are very trivial for you. So, but I still want to show you how to apply the formula we learned in the paragraph. Okay, so first one, if I ask you to calculate 4 to 1, then actually it is equal to negative 1 to 4. So the answer will be positive 2, right? Easy, right? The second one, if I ask you to do this, it's also easy, right? Because we can divide it into two parts. By using 1 as the breaking point, so the answer will be 5 minus 2, right? I just simply use the reverse order. So of course I need to add minus there. I just break the range from negative 1 to 4 into negative 1 to 1 and 1 to 4, that we can just sum these two numbers together. And I also give you an example that please just show that integral 0 to 1 plus cosine x ds is less than 3 over 2. Less than, okay? So it's also easy because we know cosine x is always less than or equal to 1. Therefore, when we calculate 1 plus cosine x, square root of 1 cosine x will be less than 1 plus 1, because cosine function always return a value less than, which is less than 1 or equal to 1. Okay, so by this one we can get this inequality. So this is square root of 2. So if you want to get the integral, of course it will be less than the square root of dx, because this is constant, so it will be square root of 2 times 1 minus 1, but 1 minus 0. So this is, of course, less than 3 over 2. Okay, so maybe let's just stop here and take a break for a while, then come back to the classroom at 10. Okay, we just have 7 minutes break. 我们休息一下。那 So we will just give some definition. The first one is area under a curve as a definite integral. So if function f of s is, remember, it should be non-negative. Non-negative means the return value for the function should be positive, or at most just 0. Okay, and integrable. On AB, then the area under the curve y is equal to f of s on AB is A So like I said earlier, if the function is positive or even the most is 0, something like that, or even, okay, so all function value will be, A to B. So the area, this is A. The function either 0, the function value either 0 or positive. So when we just calculate this function is non-negative and integrable, then its area under the curve y is equal to fx is same as the definite integral. So this is a definite integral, right? This is a definite integral. But only it should be non-negative and integrable. And it will just follow the rule. So, but if I ask you to calculate the integral from A to B, f of s, is equal to, if E is equal to area between f of s and x-axis, so you can see two types. if we are talking about this one, actually we are talking about that something like that. If the function, if f of s is not a non-negative function, so what is non-negative function? That means sometimes positive, right? But sometimes negative. Okay. So in this case, actually, if you calculate this one, that will equal to, this is the positive part, and this is positive. I assume here is C, this is D. So if you are calculating this one, actually this is positive, this is negative, this is positive. So you need to add these two amount together, but subtract this part. But if we are talking about area, A this time should be equal to integral from A to C, then plus C to D, then plus D to B. So if we are talking about area between f of s and x's, we are talking about this one. But if we are talking about integration, it should be positive half here, but subtracted by the negative half. 所以这段话要给大家的意思是说什么？一般我们在算积分的时候，其实它函数不可能都是全正嘛，所以函数如果是一个非负的，is not 好，这边写 not 哦 ，is not。如果它是一个不是非负的函数的话，代表什么？它函数一定有正有负。所以我们真的在算这个积分的时候，事实上是把这一段的大小加上这个大小减去这个大小。不要忘了，我们刚才回归到黎曼河，的时候是什么 ？A 到 B 之间我们要切割嘛，切，对不对？切完之后呢，每一段呢去贡献一点小面积出来，大家如果注意到，在这一块 C 到 D 的范围里面，它贡献出来的小面积呢，就是负的面积，负的面积呢会去跟这个比较掉，这是在算积分。但是如果题目问的是说，请问你 area between f of s and x-axis， 要你算的是这一块面积加这一块面积加这块面积只有正的没有负的，所以刚讲负面积是不太好的情况。但是黎曼的告诉我们是用那个代表点来取得高度，那高度可能是负的。于是呢，在那一段区间里面，它贡献了这个负的面积，这样知道吗？所以如果你要算，把它用来算面积，用积来算面积，你必须要把这函数呢切割成几段，这边都是正的，至少最多是零，这边是正的，最多是零，但是这一段是负的，这不要拿出来取绝对值，或者你直接加负号也可以，因为这边都是负的，但是面积真正在算几何的面积呢，面积没有所谓的负的哈。Okay, then I will give you the second definition about the average and mean value of a function. So if f is integrable of AB, then its average value. So normally we call it mean value, right? Average value. AB is average of F is equal to this one. So you can regard it as you just calculate the integral between from A to B, then divided by the length of the interval B to A to B. So we just define the average value as this one. As I told you, because this is a continuous function, so we cannot just treat it as a discrete, when we just calculate the average for the discrete type data. As I told you, we have 60 students here, so that means we have 60 scores. Then if we want to take the value, the average value, that means we can just take the summation of all of students' score, then divide it by 60, right? But since this is a continuous function, we cannot do that. We cannot do it one by one. We can just calculate the integral first and divide it by the length of the interval. Okay? So I give you an example that find the average value of f of x is equal to square root of 4 minus x squared on negative 2 to 2, right? So the average value of this function on this interval. So based on the formula we learned here, that it should be integral a to b f of s ds b minus a. So can you tell me what is a here? What is a here? Negative 2, right? Negative 2. B should be positive 2, right? And what is the function? It should be here, right? Then here should be 2 minus negative 2. So it should be 4, right? But at this moment, we didn't know how to calculate the integral. We didn't know it. 我们还不知道怎么求，所以你们可能有的同学已经学，对，我们不知道求这个怎么算这个积分，这个半圆的积分。Okay, but at least we know that this is a help part for the circle when we use 0, 0 as its center and the radius is 2. So when you calculate this, because this is non-negative function, right? From negative 2 to positive 2 for this function, it always positive. And this is still 0, right? So no any point can bring the negative function value for this integral. So when you calculate this, that is equivalent to calculate its area. So by following the formula for the area of circle, we know this should be pi times 2 squared divided by 4. So the average value should be pi over 4 over 2. So even though you don't know how to calculate the integral at this moment, but at least you know the integration can be treated as an area because the function is positive. Okay, the function is positive. So when you calculate the integral, is equivalent to calculating the area, and you already know this is a half circle, right? So that you can just follow the formula of area for circle, then you can get the integral, then divided by the length of the interval, so that we can get the answer should be pi over 2. Okay, so this is the section 3. So this is section 3. I believe we already announced that we will hold our second quiz on the next Monday, right? 下周一，因为本来是要这礼拜3了，刚好因为我要出差嘛，可是刚好说有同学要去比赛还是什么，没办法，所以我们就比到下礼拜一哈。那因为再讲下去，我怕